All right, now for the final and most fun part of this problem. They give us a new function g and tell us that g represents the height of the tree and x represents the diameter. So as the height is changing, the diameter is changing, possibly, I don't know, some kind of function relating the two. So this reminds me a lot of related rates. Yeah. So then it gives us some information. It says when the tree is 50 meters tall, so when g is 50, the diameter of the base of the tree is increasing at a rate of that. So I know that g equals 50, and this would be the base of the tree is increasing at a rate. So the base of the diameter of the base of the tree. So, and because it says rate, I know that's some kind of derivative. So x represented the diameter, and it's a rate of the diameter. So I'll call that dx dt because it's changing as time changes. So I know dx dt is 0.03. According to this model, what is the rate of change of the height of the tree with respect to time? So this is kind of going to mean something to us. It's with respect to time. So this is totally a related rates problem. In meters per year at the time when the tree is 50 meters tall. All right, guys. So we got to see if there's some more information we can figure out. We have g equals 50. We have dx dt equals 0.03. And we're going to be figuring out the rate of change of the height. So I could use the notation, since the height was g and this is the rate of that, I would use dg dt, the rate of change of the height with respect to time. So it seems like that's what I'm looking for. And it seems like I'm still missing something. I have the rate of change of the diameter, but I don't have the diameter. And that's something I need. So let's see, just like most related rates problems, there's usually something that you need to figure out before you get started. In this case, it's x. So let's figure out what x equals. I know that I'm concerned about this tree whenever its height is 50. So if I set that up, I've only got one little variable in there, x. I could totally solve that. In fact, you guys can probably do it in your heads just by looking at it. So think about that for half a second. What x value would work in that situation? Alrighty, so if you said, hey, if I plug a 1 in there, that would be 100 over 2, which equals 50. So if you plug a 1 in there, you are totally correct. If you need a more mathematical, algebraic way to do this, well, let's just, I don't know, cross multiply. 1 plus x times the 50. And 1 times 100x. So you could use your algebra skills. I was just trying to show you that sometimes you can figure the answer out just by common sense. So I know that when the tree is 50 meters tall, its diameter is 1. So I'm going to need that in the problem eventually, I'm sure. All right, let's get to the good stuff here. We have g of x equals 100x over 1 plus x. And I want to find the rate of change of all this. It's moving. So the rate of change with respect to time. So tell me, what is the derivative of g with respect to time? It's dg dt. Yes, cool. All right, that was easy. And then what's the derivative of this function over here? I hope you're saying use the quotient rule. That's how you guys sound to me. Use the quotient rule. That's what we should do, yeah. So let's do it. Low d high minus high to low over low. Low d high. So low d high. Now the derivative of 100x is 100, but it's with respect to time. So we got to keep in mind that this is a related rates problem. So it's not just 100, it's 100 dx dt. So the fact that this is with respect to time, I think I underlined that. Let's underline it again. With respect to time means I need to include that dx dt. All right, so I got my low, I got my d high, minus high, d low. And the derivative of that lower piece would normally just be 1, but because it's with respect to time, it's 1 dx dt. All right, over low, low. Over low, low, so that's 1 plus x squared. Cool, we've done a fantastic job. I hope that made sense. Now the fun part, you get to plug some stuff in. We don't know what dg dt is. That's what we were looking for. But we do know what x is. We know that x is 1. So that's going to say 1 plus 1, also known as 2, times 100 dx dt. And we do know what dx dt is. It's 0.03. So plug it in. Minus 100 times 1, so 100 times 0.03. All over 1 plus x. 1 plus x, so 1 plus 1 makes 2 squared. So very cool. We got this. I've got 200 times 0.03 minus 100 times 0.03 all over 4. 200 of those minus 100 of those leaves me with 100 0.03s over 4, and 100 times 0.03. Well, that's just 3. So I've got a beautiful answer, but now I need to write it in words. What am I saying here? 3/4? I can't just leave my answer there. That was a rate, so I would say that the tree is growing. The tree's diameter. No, the tree's height. Our function now is dg dt, so we would say the tree's height. And I'm saying growing because it was a positive number. At a rate of 3/4, and I think we was in meters, and it was dg dt, so it's meters and the time is years, so meters per year. All right, guys, that was definitely the most fun part of this problem. I hope it made lots of sense. If it didn't, then I'm sorry. All right, guys, have a wonderful day. See ya. Seriously, though, let me know if you have any questions.